Welcome to this office mix on vector addition. This is the second one in the Our Dynamic Universe section on vectors. What do you need to know? Well, you need to be able to find resultant vectors either using a scale drawing or using mathematics, but when there are not right angled triangles. I would recommend a scale diagram. Vectors are represented by a line with an arrow. The length of the line represents the size of the vector, the magnitude. The arrow represents the direction. When two or more vectors are added, we get something called the resultant. Vectors can be added using a vector diagram. Remember that vector diagrams should be drawn tip to tail. That means up one way, and then the bottom of the first one is drawn from the tip of the second one, and the resultant is drawn in. Or up that way, and then drawn in the resultant. It's important to draw them tip to tail, or your direction will not be in the same direction as the resultant, and therefore will be incorrect. The resultant of a number of forces is a single force which has the same effect in both magnitude and direction as the sum of the individual forces. Let's have a little look at what we mean from this. So vectors are not always drawn at right angles. To add them up, it's easiest to use a scale diagram, but it is possible to use mathematics. Because they're non-right angle triangles, you need to use the cosine rule and the sine rule. You are not given these relationships, so you need to remember them if you're going to use them. I would again recommend the scale diagram. Okay, let's look at a particular problem. Let's say we've got a vector that is like this, and at 45 degrees to it is something like that. Okay, now this part of the diagram is not drawn to scale. We've got, let's say, 60 newtons this way, and we've got 80 newtons that way. And we have an angle in there, 45 degrees. So what we need to do is we need to draw a scale diagram, and the larger the scale diagram, the better. So I'm going to make my line along the bottom, my 60 newtons there, and I have 1 centimeter is equal to 10 newtons, and that's my force in this direction. Notice the first diagram, the forces are coming from a point. I need to redraw the diagram tip to tail. So at 45 degrees to that line, I'm going to add on my vector here, and this is going to be 8 long. So 3, 4, 5, 6, 7, 8, like so. And my resultant vector is the line in blue. Surface is not giving me a particularly straight line. You'll be doing yours on paper. And so this one here was 80. This one here is 45 degrees. So I can use my ruler to measure how many centimeters long that line is, and I can work out what the resultant is. So that is 8, and that is 12.7. So that's 12.7 centimeters, which is equal to 127 newtons. What I then need to do is I need to work out my angle. So I need to use a protractor to measure this part here. Well, in fact, I don't need to do that, do I? Because if that is 45 degrees, although it doesn't actually look like it, then this one here must be 45 degrees. Okay, so we've got our answer that we've got 127 newtons at 0.45 degrees. It's important that you use a ruler and a protractor, and I would use squared paper to make, or graph paper to make your result the most accurate that you can do. Let's have a look at what else you could do. You could use in a different example. So an aircraft travels north for 100 km, changes course 25 degrees west of north for a further 250 kilometers. We need to find its displacement. Choose a suitable scale, say 25 kilometers 1 centimeter. Draw a diagram using pencil and protractor. Put on north, south, east, west. There's my 4 centimeters because that's 100 kilometers. Then it goes 250 kilometers in that direction, but I need to have measured the angle carefully to make sure it's the right way. Then I draw in my resultant and I measure it and convert the scale. So 13.7 centimeters times 25 gives me 342.5 kilometers. I then need to work out the angle using a protractor, and the angle I'm interested in is that one there. Well, that's the bearing I'm interested in. I can measure that angle, then I can take it away from 360 degrees. Okay, you can solve it with mathematics. Okay, you draw it roughly to scale, and you can use your cosine rule. You've got to work out this angle here, and then you can substitute it. You will get the same answer, but you are more likely to make a mistake when you're working through your answer. So I would recommend the scale diagram approach. To work out the direction, you need to use the sine rule. A over sine A is B over sine B. Need to put our resultant on the diagram there. And then you can work out that angle. So the key question from this section is, can you use the scale diagram or calculation to work out the resultant of 2 or more vectors that are not at right angles?